Well, hello. Today I'm going to be doing a quick demo/tutorial on how to create a component for use in DipTrace. Up until now I've been using mostly EagleCAD for my products, and since switching over to DipTrace I'm just going through and creating some of the common components that I use over here in DipTrace now. So I thought we'd take the Maxim MAX31855, which is a thermocouple to digital converter IC, and create the component in DipTrace. This is a nice, simple 8-pin SOIC, not too complicated, and DipTrace actually has some nice functionality to make the creation of a component like this nice and simple. So with that, we'll go ahead and take it away. So open on the screen right now, I've got a copy of the data sheet for the component, so I can reference the pin numbers and names nice and easily. I've also gone ahead and opened up the recommended footprint document, which is a second document from the original data sheet. It's actually a link to it right inside there. If you read through, you can find that. And we're going to use both of these to create our component. So the first thing I'm going to do is I'm going to go over to the DipTrace launcher here, and let's work on the component first. This is going to be the symbol that's going to be used in the schematic editor. So I'll launch that app right here. Now, what I like to do is I like to keep a lot of the components that I use on my boards in a single library. There's many different ways you could organize your components, but do what works for you. So here you can see some of the components that I've already created, and we're going to go up to component, and we're going to add new to library for our new component, and that creates kind of this empty slot down here. First thing I'm going to do is I'm going to give it a name. That's the MAX31855. Come down here to my reference designator. I'm going to give that a U. So when this component is used in the schematic capture program, it'll automatically prefix the ref des with a U and add a number. Let's see. Other than that, that's mostly what I want to set in here. We can play with these other settings in a bit. Now, one of the first shortcuts that I like in DipTrace for creating components is this type section. If I go under here, you see I can choose IC2 size. What this will do is give me a quick template for an IC. I can then go over here, I can change left pins and right pins. We'll go 4 and 4, which matches the chip that I'm designing. And if you look, you can see that in part of what it's doing is it's aligning these properly. So when we go to use this in the schematic, we'll be able to connect to these and not have to worry about them being slightly off the grid and so forth. Keeps things simple. Okay, so what I'm going to do next is I'm going to go into this pin manager. This is another neat little shortcut that they've got. This is a great way for us to name each of these pins. So I'm going to click up here on the first one. Currently it's named 1, but we want to name it something a little bit more easy to read. So if I look at the data sheet, pin 1 is ground. So I'm going to give that the name of ground. I usually like to go through and name all the pins first. And one reason for that, if we've already selected the first one and our mouse cursor is still in this name box, if I hit the down arrow on the keyboard, it automatically hops down to the next row, keeps the cursor in the name box, and I can just keep typing for the next one. Alright, so we can see the next pin here, pin 2, is a T minus. And the next one was a T plus. And then we have VCC and SCK. Pin 6 was chip select, CS. Then we have an SO, and then we have a no connect. A CS, an SO, and a do not connect. I'll use NC, just because that's what I typically use on my components. Another thing that I like to do in the pin manager is I'll go through and I'll select all of them again. I did that by clicking the last one, scrolling to the top, holding shift, clicking the first one, and you see this option here for show name. What that'll do is once I close the pin manager, it'll automatically apply a label properly aligned to each of these pins corresponding to that pin's name. Makes things a little bit easier. You can also go through here, and for each pin you can assign a type if you'd like. And you can also apply an electric designation. This is used for the ERC. So when we go through and we run ERC verification on the schematic, this could help us identify some pins. Maybe we forgot to connect a power pin, for example, or what have you. For the sake of simplicity, I'm going to leave those empty for right now. I'll go ahead and click close, and you can see it's already gone and apply those labels to each of the pins. Just like in schematic, we can move the schematic around by holding down the right mouse button, or zoom in with the mouse wheel, or zoom out. What I'm going to do next is I want to put a little label on here just so I know what chip this is easily. So I'm going to use the text tool, click out here, and then I'll type MAX31855. Now you have to hit the enter key when you're done, otherwise you're going to lose the text in your label. And we're going to put that right over there. You can either drag it with the mouse, or we can click it and use the arrow keys to tweak it. Alright, so the component is almost done. I'm going to go ahead and save the library just so I don't lose my work. What we still need to do is we need to assign it to a pattern. And we have this pattern button up here, which will let us load from our library the proper pattern. There's a bunch of different options here. Here's some SIP patterns, for example. What I'm going to do here, just to show you the full stack from component creation to footprint, we're going to actually create that pattern. And this is a simple SOIC 8. So I'm going to go back to the launcher, and I'm going to launch the pattern editor. All right, and just like in the component editor, I'm going to open up my default library that I have for my patterns. And I am going to create a new pattern. And we're going to call this SO8. Now, here's another neat shortcut in DipTrace. Again, we see that same kind of type option. And I can use, in this case, lines. This is our default for components like SOICs, SSOPs, and so on and so forth. So we want 2 lines. There's going to be a total number of 8 pads. We can then apply pad spacing and line spacing. So pad spacing is the space between our pads here. Line spacing is the space between our lines here. And you can also see that it's added this nice little measurement drawing in to the pattern as well for simplicity and ease of viewing. Now let's go ahead and we'll look at our data sheet. And we can see here we have a pad spacing of 1.27 millimeters. So come over here, 1.27. And line spacing is 4.93. 4.93. All right, so far so good. And you can see that our scale is already in millimeters, so these values are in millimeters. Now, things are looking a little squished right now because we haven't yet set the size of our pads. I'm just going to right-click one of them, go to Properties. We have Type and Dimensions. Now, the default is going to be to use the pattern's pad properties. So this is kind of a default for all the pads in this pattern. If we click the button here, this will bring us to where we can set that for all of the pads in this pattern. Now, let's see, width and height. We know that we want our height of the pad to be 0.53 millimeters. Which here looks like they swap width and height, but that's fine. And the height is, we're going to say 1.98. All right, this is also where you could change it from a surface mount component to a through-hole component, or you could even change the shape of the pad. We're going to just use rectangles because that's what we want here. If you were doing a through-hole type pad, this is also the dialog where you would set what size hole. All right, we're going to go ahead and click OK here and OK here. And you can see things are looking a lot better. All right, now let's see here. Just as far as pad numbering, and let's say this was actually facing vertical. Of course, this would be pad number 1. If I hover over it, you can see that this is in fact pad number 1, pad 2, pad 3, pad 4. Hop up here, pad 5. So this is numbered just like the component will be. So that's really all you would need to do to set up a basic footprint. You could go ahead, you could add some silicon here as well if you wanted to approximate the size of the component. What I usually like to do as well is add a nice designator for pin 1. So when I go to assemble these later on, I'll know because of this little mark that the pin next to it is my pin number 1. That'll make it easy to align everything properly. And you see that I was just using the little drawing tools up here, and the dialog was set to top silk, so this is actually creating these markings in the top silk layer. Other than that, I don't need to add my reference designator manually here because it'll automatically do that later. And I don't usually like to put the chip information. Like I'm not going to put MAX31855 in here, so I will leave that out as well. So we're going to go ahead and hit save here. So this pattern has been saved to my library. Now if I go back over to the component editor, I can click on pattern now. I can scroll down here. Now I've already got my library in here for my patterns. If you had created a new one, to add it, all you'd have to do is click add up here, scroll over to where your libraries are, choose it, and click open, and then it'll show up in the list. Now we can click it. We could either type some letters and click search to narrow down, which will search everything, or by just clicking my one library, I can kind of scroll down and find the one that I had created. Alright, now we want to set up all the different pins and so forth. So I can zoom in on my pattern to make it a little bit easier to see. Now, the way we numbered these, they're already numbered properly. So pin 1 was ground, pin 2 is T minus, pin 3 was T plus, so on and so forth. Now, because we have used the same numbering on the component that we used on our pattern over here, everything's already kind of aligned properly. If we wanted to change this, let's say it was wrong, we could actually just click over here on the pin we want and then come over here, click on the pad we want, and it'll automatically assign the proper matchup. Alright, so everything is all set over here. We're going to go ahead and click OK. You can see the pattern is now properly associated over here. I'm going to click save up here, and that's it. So we've created a brand new component. We could now come over to schematic capture. Go over to our library, and our new component is already ready to use. And that's it. And you can see it's even added the reference designator right up top there automatically. So definitely pretty cool. DipTrace has a lot of neat functionality to make this really quick and simple. Maybe a future recording here we'll do a TQFP or something with 4 sides. Those are really just as simple. You can use the same kind of a shortcut for a 4-sided IC. And in the future, I also plan on doing a quick tutorial on how to create simply components for maybe odd shapes, odd plaid basements. So, all right, very good. Thanks for watching, and be sure to subscribe. I'm sure we'll have lots more fun videos to check out coming up soon. All right, thanks everybody.